Okay, so hello and welcome back. So in this video we will work on the rest of the problems, and we have example number 13, which is tan of 1/2 sine inverse of 2x over 1 plus x squared plus cos inverse of 1 minus y squared over 1 plus y squared. So you want to find basically the tan of half of this angle, and actually what you want to do here is you want to find the values of these expressions, meaning that you want to, for the absolute value of x less than 1, and for y greater than 0, and x times y less than 1. Okay, you want to find the value. Okay, now in order to solve this problem, what you can do is that first let's take a look at the let me get something done quickly. Okay, so now if we take a look at the inverse trigonometric functions and the properties of them that we discussed before, if we take a look at them, here we said that the sine inverse of x plus the cos inverse of x is equal to pi by 2, tan inverse of x plus the cot inverse of x is equal to pi by 2, and cosecant inverse of x plus secant inverse of x is equal to pi by 2, right? Now, we said that basically the tan inverse of x plus the tan inverse of y is equal to this thing here, and we said that basically 2 times tan inverse of x is equal to sine inverse of 2x over 1 plus x squared, and over here we said that cos inverse of 1 minus x squared over 1 plus x squared, this thing over here, is equal to 2 times tan inverse of x. So I can use these two results in order to write this thing here, right? Which means that I can write 2 times tan inverse of x is equal to sine inverse of basically 2x over 1 plus x squared for the absolute value of x less than or equal to 1. And also we said that basically 2 times tan inverse of x is equal to cos inverse of 1 minus x squared over 1 plus x squared, right, for x greater than or equal to 0. So we said that these two results were true, right? Okay, so basically you can see that of course there is a slight problem here, and that is basically here we are saying that 2 times tan inverse of x is equal to sine inverse of this expression if x is less than or equal to 1, or for x is less than or equal to 1, meaning that 1 is there. 1 is a part of the domain of the sine inverse function and the tan inverse function. And here we are saying that 2 tan inverse of x is equal to cos inverse of this expression for x is greater than or equal to 0, meaning that basically positive 1 can be can be entered here or 0 can be entered here. There is no problem with that. Now what that means is that you can, well, of course there is another problem, and the problem is that in the beginning of this section we were told that by the text that basically these domains are not sometimes not very accurate. So that problem is also there. But at the end of the day, if I assume that this domain is accurate on this inverse trigonometric identity, then that means that I can actually use it here in order to write it as for example 2 tan inverse of x and 2 tan inverse of y here, because here we are talking only about x's where the absolute value of x is less than 1, right? And here we are talking only about y's that where basically y is greater than 0. Now of course over here, as you can see, basically for example y, if I were talking about y's here, then y can actually be equal to 0 as well, or over here x can actually be equal to 1. But that's not a problem here, because the domain of these two, which are our identities, are actually a bigger set than the domain that we have specified here, which means that you can use these two over here in order to rewrite these values. So you have no problem with that. So now what you can do is that you can write this as the tan of basically 1/2 of, so sine inverse of 2x over 1 plus x squared is equal to 2 tan inverse of x. So this is 2 times tan inverse of x, and cos inverse of 1 minus y squared over 1 plus y squared for these x's, for these y's would be 2 tan inverse of y, 2 tan inverse of y, which means that now we need to basically somehow put these two together. Now the way that you can put these two together is that if x times y is less than 1, you can use this identity tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y over 1 minus xy, and put them together. Meaning that I can write basically tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y over 1 minus xy for x and x times y less than 1, right? So what I can do is that I can write this as the tan of 1/2 of, and then I can basically take this 2 out, meaning that I can write it as 2 times tan inverse of x plus tan inverse of y, and then you can basically this is the tan of, okay, if I take this as the whole angle, then I can simplify these two as well. And the tan inverse of x plus tan inverse of y, I can write it as the tan of basically tan inverse of x plus y over 1 minus xy, right? I can do that, and then that basically means that this is equal to x plus y over 1 minus xy. And that is basically the value of this expression, right? So pretty simple, but you need to just simply pay a little attention to the problem and see what you have there, and then put all of the trigonometric identities together, and all of the trigonometric identities that we have, all the trigonometric identities that you have from class 6, NCERT class 6, all the way up to class 12 can be written in only a couple of screenshots, meaning that I have actually made all of these screenshots mainly because I cannot remember them. Otherwise, there is no reason to do that. I mean, in the past, I used to be able to remember them. Trigonometric functions. Okay, but back then in college, we had to write them down many times so that we could remember them. But right now, it's really not. I mean, not necessary for me. You can of course do that, and it doesn't take much time to learn all of them. But what I mean to say is that all of the trigonometric functions, I mean everything that we have done related to basically trigonometric functions, you can write them as, this is the radian to degrees conversion, which is something that you don't really need to worry about that. Then you have these trigonometric identities, one here. Then you have basically these trigonometric identities. So these are pretty simple. We talked about that, and you can easily remember them. There is no problem with that. These trigonometric identities are also, they're pretty simple. You can remember them. There is these trigonometric identities for cos of 2x, sine of 2x, and tan of 2x. That is also very simple. Sine, cos, and tan of 3x, that's also simple. There is no problem with that. There is basically these trigonometric identities, that cos of x minus cos of y, cos of x plus cos of y, and so on and so forth. So that's also simple. There is these same formulas related to the formulas that I just showed you, and there is these formulas that were left out from the formulas that we did here. So you need to add those formulas to this list as well. And then there is a table which you already know everything about, meaning that if you know basically 0 to 360 degrees, all of these main angles, the sine and cos of them you already know, and then whenever you need, you can calculate all the other trigonometric ratios related to these angles. So this is everything that you need to know, starting from class 6 all the way up to class 11. It's not really not much. It's really nothing. And then when it comes to the inverse trigonometric functions, all you need to know is basically these domains and these ranges. And of course we talked about them, how you can basically limit things, and then or put a limit on the domain of the function so that you get the range of them, and so on and so forth. And there is only these formulas here that you need to know, and of course once you work with these examples, you will automatically learn them. So there is really nothing much in this whole concept of trigonometry. And the good news and the good thing about that is that you usually can do a lot, I mean, and by a lot I mean really a lot, if you know basically algebra. If you know algebra and trigonometry, right? These two things, these two concepts, if you know them well, you can take any, for example, algebra-based physics course. You wouldn't even need calculus, right? So these two concepts, I mean, of course, algebra and trigonometry, you can argue that they are basically a combination of all the different concepts in mathematics, but let's say that all the way up to class 10, 11, if you know simple algebra and trigonometry, you can simply get into science, you can get into electronics, you can get wherever you go. And of course then along the way you will need some calculus, which is not really that, I mean, that big a deal. It's just a couple of chapters in this book and you can learn that as well. But now let's add calculus to this list as well. Now if you know calculus, algebra, trigonometry and calculus, these three concepts, meaning that everything there is from class 6 all the way up to class 12, then these three simple concepts will give you so much power that you couldn't even imagine if you haven't already worked with these concepts. Meaning that power in terms of mental power, in terms of power in your career, power in the any kind of power, because these days, of course, the world is a purely knowledge-based world. So you cannot really I mean, knowing algebra, trigonometry, and calculus is really a must, right? Okay, so now enough of talking. We will continue with the exercise. Okay, so the next question that we have here is question number 14, and that is basically question number 14, which is if sine inverse of 1/5 plus cos inverse of x if this value is equal to 1, then find the value of x. Okay, so basically you have the sine inverse of 1/5 plus cos inverse of x, and if you take the sine of that is equal to 1. Now we have to make a couple of assumptions, meaning that I can say that, so you know that the sine of pi by 2 is equal to 1. Also the sine of basically 5 pi by 2, also the sine of 5 pi by 2 is also equal to 1. Now the sine of, if you go around the circle, what happens is that, so this is basically 0, this is pi by 2, this is pi, this is 3 pi by 2, and this is 2 pi. And then over here you have basically you have 3, 4, 5 pi by 2, and then 5, 6, 7 pi by 2, and then you have 9 pi by 2. So then you have 9, 11, basically 13 pi by 2, and so on and so forth, right? So that means that basically you can say that the sine of x is equal to 1 if x is equal to basically 1, 5, 9, 13. So if x is equal to I don't want to find the rule over here, but you could say that x is equal to, for example, pi by 2, 5 pi by 2, 9 pi by 2, and 13 pi by 2, 13 pi by 2, and so on and so forth, and 13 pi by 2, and so on and so forth, right? Which means that I could assume that basically sine inverse of 1/5 plus cos inverse of x can be any of these values, and the sine of that the sine of that angle would be equal to 1. So now we need to find a way to decide what the angle actually is. Right? So now let's see how they have solved the problem. So the way that you can solve the problem is that so basically they have argued that since basically the sine of basically sine inverse of 1/5 plus cos inverse of x is equal to 1, then basically you can say that, therefore you can say that the sine inverse of 1/5 plus the cos inverse of x is equal to the sine inverse of 1. Right? So that you can say the sine inverse of 1. Now they have taken the sine inverse of 1 as pi by 2, although all of those angles, well, of course there is one consideration here. I can actually make the assumption that the domain of the sine inverse function, as we saw over here, the domain of the sine inverse function goes from negative pi by 2 to pi by 2. So then that simplifies everything, and so I can simply say that based on the definition of the sine inverse function, I can say that the sine inverse of 1 is equal to pi by 2. And so the sine of 1/5, the sine of 1/5 plus the cos of, actually that's supposed to be the sine inverse. The sine inverse of 1/5 plus the cos inverse of x is pi by 2. That I can write. Now, in the formulas that we had, we said that basically if the sine inverse of x plus the cos inverse of x is equal to pi by 2, if x belongs to, for all x's belonging to -1 to +1, right? So what that means is that I can write, I know that basically we can say that we know that the sine inverse of x plus the cos inverse of x is equal to pi by 2 for all x's belonging to the interval -1 and 1. And so I can, based on this, I can basically conclude that since I have the sine inverse of 1/5, then x is equal to 1/5, and that basically fits with the condition that I have here as well. So I have no problem there, right? So that is that. Of course, these are all periodic functions, but as long as you're working with the definitions, you have no problem. So, question number 15, you have if the tan inverse of x minus 1 over x minus 2 is equal to, plus the tan inverse of x plus 1 over x plus 2 is equal to pi by 4, then we need to find the value of x. The value of x. So basically we have if the tan inverse of x minus 1 over x minus 2 plus the tan inverse of x plus 1 over x plus 2 is equal to pi by 4. You want to find the value of x. Okay, so now to solve this problem, I don't know where I really was. Okay, now to solve this problem, basically I did solve this problem in a different way, and this is the second time that I'm solving this problem. Now, what we have is that we have the tan inverse of x minus 1 over x minus 2 plus the tan inverse of x plus 1 over x plus 2 is equal to pi by 4. So we know that the tan inverse of x plus the tan inverse of y is equal to the tan inverse of so we have a basically well, there is a problem here. So you see in the solutions, for example, what they have done is that they have used the formula. They have used the formula, for example, the tan inverse of x plus the tan inverse of y is equal to the tan inverse of x plus y over 1 minus x times y, right? And that is for x times y is less than 1. Okay. Now, what that means is that, well, of course, provided that the domain of these identities are accurate and everything, but I'm making the assumption that for example, the domains of these identities are accurate, meaning that when you say that x times y is less than 1, that means that basically you can use this identity only x times y is equal to is less than 1 and not otherwise not, right? That means that if I want to use this identity in order to rewrite this tan inverse and tan inverse, rewrite them together, I need to make sure that x times y is less than 1. That meaning that I need to make sure that basically that if I multiply this, that if I multiply x minus 1 over x minus 2, if I multiply it by x plus 1 over x plus 2, that basically if this thing is less than 1, then I can use this formula, otherwise I cannot use it. Now if you do this calculation, what you will get is that for example, you will get basically x minus 1 times x plus 1 over x minus 2 times x plus 2, right? And so that is a minus b times a plus b, which is equal to a squared minus b squared, which means that I can write this as x squared minus 1 squared. And then this is again the same thing, a minus b times a plus b. I can write it as x squared minus 2 squared, which is equal to 4. So that's x squared minus 1 over x squared minus 4. Now this ratio, if I write this as x squared minus 1 over x squared minus 4, this ratio is always basically greater than 1, except for the times when x is equal to 0. You see, when x is equal to 0, then x squared minus 1 over x squared minus 4 gives you basically negative 1 over negative 4, which is equal to 1/4. So in this case, basically, in this case, it seems that it's actually less than 1. Now, if x is a positive number, for example, if x is a positive, suppose that, for example, x is equal to, I don't know, 3, for example, then if that is the case, then x squared minus 1 over x squared minus 4 is equal to basically 9 minus 1 over 9 minus 4, which is equal to basically 8 over 5, which is greater than 1. Okay? And over here, if x is a negative number, meaning that, for example, suppose that x is equal to negative 3, again you will have the same thing, meaning that negative 3 is raised to the second power becomes positive 9 and positive 9, and you will have 8/5, which is greater than 1. That means that x times y, which is, if I take this as x and if I take this as y, x times y is actually greater than 0, is actually greater than 1. Over here again, x squared minus 1 over x squared minus 4 is greater than 1. That means that this ratio is greater than 1, except for the times when, except for the occasion when x is equal to 0, right? Which means that, and this formula cannot be used if x times y is less than 1. If x times y is less than 1, I cannot use this formula, meaning that over here I have to specify that x is not equal to 0. Now, if x is not equal to 0, then I can use this formula, right? So what I'm going to say is that basically assuming that x is not equal to 0, we have basically the tan inverse of, then we have basically this formula here. We can use this formula, and so the tan inverse of x minus 1 over x minus 2 plus the tan inverse of x plus 1 over x plus 2 is going to be equal to the tan, or I could simply say basically the LHS. The LHS becomes basically this expression, which is the tan inverse of basically the tan inverse of x minus 1 over x minus 2 plus x plus 1 over x plus 2 over 1 minus x minus 1 times x minus 2 times x plus 1 x plus 2, right? So that is basically this, and so that is that I can simply say that is equal to pi by 4, right? Now let's calculate this part, because and get it out of the way, and then we will take care of the rest of this problem. So you have x plus 1 over, so I can add these two together, I'll get x minus 2 over, or x minus 2 times x plus 2. And dividing this over here, I'll get x minus 1 times, I'll get x minus 1 times x plus 2. And over here, I will have x minus 2 times x plus 1. Right? And then the denominator becomes 1 minus, it's actually nothing but 1 minus x minus 1 times x plus 1, x minus 2 times x plus 2, right? So if I subtract this, I will get the LCM. I can take that x minus 2 times x plus 2, and over here I'll get x minus 2 times x plus 2, and then subtract from that x minus 1 times x plus 1. And then I can simplify these two together and rewrite this as, well, I will have x squared plus 2x plus 2x minus x minus 2 plus x squared plus x minus 2x minus 2. Let me check this. So x squared plus 2x minus x minus 2 plus x squared plus x minus 2x minus 2. And then over here I have x squared x minus 2 over times x plus 2 is equal to x squared minus 2 squared, which is equal to 4, minus, over here I have basically x squared minus 1. And so I can simplify these here. And I can simplify these two. And so I will get basically 2 times x squared, 2 times x squared minus 4. And then I have x squared minus 4 minus x squared plus 1. And these two will be cancelled out. And then negative 4 plus 1 is equal to negative 3. Right? So that's 2x squared minus 4. So I can write this as the tan inverse of 2x squared minus 4 over negative 3. And that is equal to pi by 4. Which means that basically, 2x squared minus 4 over negative 3 is equal to tan of pi by 4. Now tan of pi by 4 is equal to 1 basically, right? That is equal to 1. So that you can write as 1. So you have 2x squared minus 4 over negative 3 is equal to 1. That means that 2x squared minus 4 is equal to negative 3, which means that 2x squared is equal to basically 4 minus 3 is equal to 1, which means that x squared is equal to 1 divided by 2, which gives basically x is equal to plus or minus 1 over the square root of 2. Well, it's actually which is actually possible. There is no problem with plus or minus 1 over square root of 2. But of course, all of these depend on, once you're using these concepts, for example, in physics or somewhere else, or in basically in some practical problem, then the answers that you provide here, for example, whether you write it as positive 1 over square root of 2 or negative 1 over square root of 2, that depends on the bounds basically that you have on your problem. You can, this is just what we do in mathematics. Okay, so that was question number 15. Now question number 16, you want to find the value of sine inverse of sine of 2 pi by 3. Sine 2 pi by 3. That is simple. You don't need any formulas or anything for this. So you know that basically, of course, you can use some of the formulas that you have that we have derived before, meaning that 2 pi by 3 is actually pi by 3 is actually so basically pi by 3 is actually 60 degrees, right? So that is 120 degrees. So 120 degrees is nothing but so basically 120 degrees is basically some angle over here, which is 90 plus 30, right? So this is 30 degrees, this is pi by 2, for example, and this is 120 degrees over 2 pi by 3. So I can write 2 pi by 3 as, and I want to find the sine of 2 pi by 3. That means that if I have some angle over here in such a way that this angle also becomes 30 degrees, this angle would be 60 degrees. So then, as you can see, the sine of these two angles are the same values, meaning that I can say that the sine of 60 degrees is the same thing as the sine of 120 degrees, right? And we also had some formula in terms of pi by 2 and so on and so forth. We said that, for example, the sine of pi by 2 plus x plus some angle x is going to be equal to, since I have pi by 2, sine becomes cos, and over here you have your angle x. There is only the problem of this being basically negative or positive, and that is let me take a look at this formula. So we said that the sine of pi by 2 plus x is equal to cos x, as you can see here, right? The sine of pi by 2 plus x is equal to cos x. Now, so this formula, I can use this formula also to find the sine of 120 degrees. Now, if I calculate the sine of 120 degrees from here, the sine of 60 degrees is equal to square root of 3 by 2, and that is equal to the sine of 120 degrees, which is the same thing as the sine of 2 pi by 3, right? Now, here we said that instead of basically what I want to calculate is the sine of 2 pi by 3, sine of 2 pi by 3, I can write it as the sine of, as this formula suggests, pi by 2 plus pi by 6. Pi by 6 is 30 degrees, right? So, which is the same thing as this formula suggests, is the cos of pi by 6. Now, the cos of pi by 6 is equal to basically the cos of 30 degrees. The cos of 30 degrees is equal to square root of 3 by 2, which means that the sine of 2 pi by 3 is equal to square root of 3 by 2. So you can do all of these formulas. Basically, all of these formulas you can for them you can use the unit circle whenever you're calculating something. But when you're using algebra and trigonometry, of course, then sometimes you have to use these formulas. There is no other way. So basically then this is equal to, of course, sine inverse of sine of 2 pi by 3 is just simply equal to 2 pi by 3, but meaning that you can write this as the sine inverse of, for example, square root of 3 by 2, and then basically find but of course there is a problem here. Now the problem here is that basically, let me write it down, which is of course pretty important. See over here, basically the sine inverse, when we say that the sine inverse of, sine of x, that is equal to x if x belongs to the interval that is to the interval basically to which we limited the domain of the sine function. So we limited the domain of the sine function to go over here to the inverse trigonometric functions. So we limited the domain of the sine function to negative pi by 2 to pi by 2, and then based on that we got some definition for the sine inverse function, which means that here if x belongs to negative pi by 2 to pi by 2, then the sine inverse of sine of x is equal to x, right? Now, so which is the principal value branch of the sine inverse function. This would be the principal value branch of the sine inverse function, right? Now, so the sine inverse of sine of 2 pi by 3 is equal to basically now I have to write the sine of 2 pi by 3 in such a way that it gives me some angle that has the same sine value, but basically in this domain, meaning that in negative pi by 2 to pi by 2, right? So and we saw that in the unit circle why that is. So negative pi by 2 to pi by 2 is basically this is negative pi by 2 and this is pi by 2, right? So that is basically, you can go from here all the way up to here. If basically x belongs to, if this x belongs to this domain, then of course then I could write, for example, the sine inverse of sine of x as x. But as you can see, 2 pi by 3 is some angle over here and doesn't belong to this domain. So I have to somehow bring my angle somewhere over here. And for that I need to basically write my angle in terms of well, I could, for example, use for example the sine of so 2 pi by 3 is some angle like 120 degrees. So 120 degrees, you have a 30 degree angle over here, you have a 60 degree angle over here. That means that this 2 pi by 3, you can write it as you can write it as basically pi minus basically pi by 3. Pi minus pi by 3, right? So and so if I have the sine of basically 2 pi by 3, I can write it as pi minus pi by 3, and then I can write sine over here, and but of course I need to check whether my formula is correct, because otherwise I wouldn't be able to use it here really. So let me check, let me take a look at these formulas, because now you can see that, for example, if I write the sine of basically x is equal to sine of pi by pi minus x. So you have no negative sign over there, so you have no problems. So that means that the sine of x, we can say that the sine of x is equal to the sine of pi minus x, and therefore instead of writing sine of basically sine of 2 pi by 3, I can write sine of pi minus pi by 3. So I can write this as the sine inverse of sine of pi minus pi by 3. And that way I can write my angle, right? Now of course you know that based on this formula, when you have the sine of pi minus x, that is equal to the sine of x, right? Which means that the sine of pi minus pi by 3 here, pi minus pi by 3 here, that is equal to the sine of pi by 3. Which means that I can write this as the sine inverse of sine of pi by 3, and now this angle is in the domain of in this domain, which is negative pi by 2 and pi to pi by 2, and so now I can write it as pi by 3. Otherwise, when the angle is 2 pi by 3, of course I couldn't just simply directly write it that way. And so basically what that means is that the sine inverse of the sine of 2 pi by 3 is actually not 2 pi by 3 but pi by 3. Okay. Now I'm going to end this video here, and in the next video we will continue. I don't know how many these are left. Not much really. This was question number 16. There is a couple more left here, so we will discuss them in the next video. Thank you.